Hello, everyone. Thanks for joining us. On behalf of the team here, welcome to our North American Industrial Control Panel Symposium for 2023. So glad that you all could join us. Everyone, before we move on, I would just like to say a couple of words about our disclaimer here. Now, please understand the examples that we show you today, that's basically all they are, and they may not be relevant for your application. So, we're going to cover two topics today. Well, actually, we have two subtopics. And the first topic here today, you see it, we're talking about which is the U.S. standards and are relevant for industrial control panels. And the second topic is, okay, we're talking about the relevant news and clarifications of UL508A and so forth. And today we have our expert here, Maximilian Crayon. We know him as Max, very intelligent and informative about his topic. And Max, we've heard so much about UL and industrial control panels, but Max, what in the world really is behind this topic of industrial control panels? Because it's always a little bit of questions there about it. So give us a little bit more detail concerning that.
Thank you, Robert. This is a nice question because an industrial control panel is first of all a cabinet with electrical equipment inside, like you see here. But not every electrical cabinet is an industrial control panel. There's something special with the electrical panel, and this is because of the application. For example, you see here an industrial control panel is a panel which controls, as a first example, an industrial machinery. Industrial machinery is a producing machine. Material came in, and on the other side, products came out.
Okay.
Could be cars, could be planes, could be clothes, could be everything. Yes? And this machine is controlled by industrial control panel. So we can say industrial control panel is the brain and the muscles of an industrial machinery.
Okay.
Yes? But industrial control panel not only controls industrial machinery, there are also some other applications, like you see here, cranes, fountains, irrigation, or fuel burning equipment.
Wait a minute, Max. Fuel burn. What do you mean exactly when you say fuel burning equipment? Because a lot of things burn fuel. What's the idea behind that?
It's, for example, the classic is if you have a big oven to heat up plastic or something else, yes, independent what you want to heat up.
Yeah. Okay.
Then you need a flame control to bring the temperature, the energy, and so. And this control of the flame, the temperature and the heat, is a task of the industrial control panel.
Okay.
Yes.
Okay.
So you see, control panel means we control something. We control industrial machinery, and we can also control flames, for example, in an oven.
I see.
Yes. And for the other one is here also air condition. It also needs a controlling, not to get too cold, not too hot, and you know what I mean. Yes.
Yes.
And there's something nice application, or the Disney parks. Yes, could also has to be controlled. The power, the turning around, the roller coaster, whatever you can mean.
Yes.
And if they are connected with water, because you know we have electrical power and we have water, could get dangerous. And for this, we need industrial control panel.
So actually the topic is relevant just about everywhere.
Yes. Normally it is made 99% of my trainings I have to do with the controlling of industrial machinery. Very minority, the other one we see here about flame control or Disney parks. I never made a configuration of a Disney park, yes. But maybe come in the future. But here is a focus. If you are talking about this control panel, it's a thing which controls industrial machinery and maybe other applications.
I see.
Okay.
Now, when you say other applications, could you give us an example there?
Yeah, this is here. I wrote them all here.
Okay.
From crane control, water parks, irrigation fountains, and everything. Yes.
Okay.
These are definitely a task for industrial control panel.
I see. Now, I know that you wanted to bring up the topic of the electrical code.
Yes. Give me a minute. just a moment.
Yeah.
For example, the biggest is the classic is an industrial control panel is normally built custom made for specific industrial machinery.
Mm-hmm.
And the industrial machinery is normally located in a big factory,
Okay.
in an industrial building.
Okay.
But
I see.
here I want to mention that not every cabinet which is equipped with electrical installation is industrial control panel.
Mm-hmm.
Because you can imagine if you have a big industry building like a car manufacturer,
Mm-hmm.
you need a switch gear, you need transformers, you need switchboards to distribute the power before it gets to the industrial control panel.
Okay.
And there's one conductor which is pretty special named. This is always important, which brings the power from the switchboard to the machine, to the industrial control panel. And this specific cable, it is called machine supply circuit.
Okay.
And this is important because the man who designed the industrial control panel has to make the design so that it fits to the building installation.
Mm-hmm. Okay. It has to be compatible. Yeah.
Yes. And now we come to it. What is now the right standard, you ask me? Yes? Because there exist different standards for different tasks, for switchboards, for switch gears, and of course for industrial control panel.
Mm-hmm.
But before we have to go in this definitely specific standard, we have to go to a building electrical standard.
I see.
And this is called, because the danger of the industrial control panel is created in an industrial building.
Okay.
It could be also, you can find the panel also in a commercial building.
Now, is this this National Electrical Code, is this only irrelevant for buildings?
Normally, yes. So if you have a building in America,
Mm-hmm.
then the National Electrical Code is the one and only standard for doing this.
Okay.
So but we talked about applications. So in every application
Mm-hmm.
where non-qualified person of electrical knowledge, yes,
Mm-hmm.
are involved with electrical power.
Okay.
Could also be outside of the building.
Mhm.
For example, in the Disney park, for example,
Mhm.
if it's water and electric power come together in specific dangers, then also the NEC, the National Electrical Code, is a good standard for doing this.
Okay. I see, Max. Now, I understand that this topic of, or should I say another phase of we talk about UL508A.
No, just a moment.
Oh, I'm a little bit. I'm asking questions that don't pertain. Okay, got it.
Okay, so this NFPA, we have to look on it.
Yes.
And you can accept this is more than 1,500 pages.
Okay.
It's a big, big thing. And the idea is now to look in a specific chapter of industrial control panels.
Mm-hmm.
And if you do this, then you find the chapter 409.
Okay.
This is specially written for industrial control panel.
Mm-hmm.
And this is now our topic.
Okay.
And here you see this article 409,
Mhm.
the scope. It covers industrial control panel for general use
Okay.
and specific use.
So it's basically the guidelines.
Yes.
Industrial
And
control panels.
and little bit down under the scope,
Mm-hmm.
there's another nice information note. You see this?
Okay.
And the information note tells us if you're looking for a standard which helps you in designing
Mm-hmm.
the industrial control panel to make the industrial control panel safe,
Yes.
then please take the UL508A.
Okay.
And this is information note right down under the scope.
Okay.
So for me, when I look into the NFPA,
Mhm.
NFPA 70, the NE code, and I want to know what is the right standard for the industrial control panel, then I know I have to take the UL508A.
I see.
And then I comply also the NEC. You see here in this picture.
Mm-hmm.
So because the NEC refers to the UL508A, everything is fine. If I'm using the UL508A for designing industrial control panel.
Okay. Now can I ask the question I was going to ask before?
Okay, sorry.
Concerning the 500 alpha, because I know things change always now, and I was wondering if you could enlighten us a little bit about, let's say, current news or relevant news, and certain type of clarifications and things like
Yes,
that.
you see this here. Just before we come to the news, give me a chance. You see this. We just talked about the industrial control panel.
Yes.
But remember, 99%, 99.9% is always the industrial control panel used by industrial machinery. And you can imagine that industrial machinery has also inside electrical equipment. There are motors inside. They have power circuit, control circuit. They have push buttons. They have also displays and everything to control by humans the industrial control as an industrial machinery.
Okay.
And now it makes no sense only to have a detailed look on the industrial control panel. It is also important that also the industrial machinery is also safe.
Okay, I see.
And if you look now in the neck, in the NEC, again, then you see in Article 670 that the NEC gives you also an advice, an information note. Please use the NFPA 79 to make a safe industrial machinery. So for the electrical equipment of the industrial machinery, the NFPA 79 is the right one. And for the industrial control panel, the UL508A is the right one. And now you see this here on my little drawing.
Yes.
The building itself should be designed by the NEC. The panels should be designed by the UL508A, and the rest, the industrial machinery, shall be designed by the NFPA 79.
I understand.
Okay, and now let's focus now only on the UL508A.
Got it.
Now we come to the...
Great. Well, we're talking about the current news and clarifications because, as I mentioned, so many things change so quick nowadays, and a lot of times people think that they are current as far as things changing. But we know that there's a lot of other factors involved in that. So could you go into detail a little bit about that, for example?
Yes. I think it's very, as you told me right now, everything is changing, especially the standards.
Yes.
And if the standards is changing, because they want to have more technical safeties in the standards, then we have to use always the newest one, and we have to change them. So now it's a good idea to show you what is the relevant news and the clarification of UL508A.
Sure.
Thank you very much. But before, I need to set up my glasses and to look in my computer now.
Let's have it. Let's do it.
That's great. Okay. So, ladies and gentlemen, before I start with the news and the clarification, let me have a little look on the structure of the UL508A. The structure of UL508A starts with the part number 1. Part number 1 is for the general use part for industrial control panels, and there you find everything. You find power circuits, control circuits, wire dimensioning, everything which is important for each and every control panel. But whereas in part number 1, there's also a part number 2. And the part number 2 is for the specific use parts. You remember? And one of the most important specific use part is the industrial machinery. So the chapter 65 to 67 is primarily to use to the part number 1 if the industrial control panel controls an industrial machinery. But as I told you in the beginning, there are also another applications like this you see here, from crane control to the water park, Disney's and flame control, marine, and everything you see here. And in the specific use part, you see chapter number 80. And chapter number 80 is for elevator control, but I can tell you in the newest standard, in the newest version of the standard, the elevator control chapter is deleted. Yes, so you see, because he put all the information in a special standard. This is the ASME Alpha 17.1 and 17.5. This is especially standard only for elevator control, and they put this out. And if you have this design, so you don't find this elevator control anymore in the newest standard of UL508A. By the way, it's now deleted. And now there's another, after the part number 2, they have the chapters of supplementaries. They started with an S. They have 2 of them, SA and SB. SA is also not anymore here. It is put it out. This has not happened last year, some years before. They put this out and have an independent PDF data sheet which you find here on the internet address, what you show here. SB, the supplement B, SB, this is, I think, the most important chapter in the UL508A. And this is for the short circuit current ratings or determination of the short circuit current of the overall industrial control panel. And of the rest, after the SB, they have some appendix A, B, C, and D. C is reversed for the future use, so you don't find any content there, yes. So we have in reality only appendix A, B, and D. So this was a very short introduction in the structure. Now let's come to the main part now. What is really new? And there's something new, definitely. And you see here it's concerning the branch and feeder circuit spacings. It's a chapter 10.2 definitely for feeder circuit. And as we know, everybody knows that it is necessary if you have a feeder circuit conductor and you connect this into a terminal in a branch protection device, then we need higher spacings. And we do this here with specially equipment. You see here the wording of the standard branch conductor variable spacings are written in the table 10.1 or 10.1A. And these are smaller spacings. These are small spacings, not high spacings. And the feeder conductor, which comes into the branch circuit protective device, has higher spacing, and these higher spacings you find in table 10.2. What is now new? And that is okay. And this is the reason we need the higher spacing equipment on top of the branch circuit protective device. This is now what is new now. And then you see here the wording that spacings accordingly table 10.1 or 10.1A, this is the smaller spacings, are now for factory wiring terminals. So now we see if the branch circuit protection device is terminated in the factory of the industrial control panel, then we need only, you see here, the spacings of table 10.1. And these are the smaller spacings. That means nowadays these smaller spacings is now not necessary anymore if the conductors on top of the branch circuit protective devices are factory wired in the branch. So we don't need this anymore. But I must tell you, there's a little mismatch between the UL508A and the product standard UL60947-4-9. Because this is the product standard of the branch circuit protective device, of this combination motor controller. And there you see here in my red area that the terminals on the line side of a self-protected combination controller shall comply with the spacings requirement in table 4.1.2.1 in the UL 60947-4-1. And these are the higher spacings. So there's a mismatch. And because of the mismatch of both of these standards, we recommend strictly not to get problems in the improvement. Please always use higher spacings on top of the branch circuit protective device. It is new, but maybe in the future they make an alignment between, and then we can forget the higher spacings equipment here. Now let's come to the next news. There's another new chapter here, what we see here. This is because everybody knows about how to protect a control transformer or power supplies. And if you pick up the power for the control circuit, you see here on the left side, directly from the feeder circuit, then everybody knows only a circuit breaker or a fuse can be used to protect a power supply or a control transformer. Yes? A combination motor controller is no option. Yes? You need a circuit breaker or a fuse. And this is the reason we make a manufacturer notice that all our power supplies creating DC 24 volts shall be protected by a circuit breaker. Can be protected by a circuit breaker. You see an example to do this, yes. And then we have also here on the internet a link which gives you very detailed information about individual tested combination of protection of a power supply. But what is now new? You can imagine a lot of people ask me how we can use a combination motor controller for protection of a power supply. And this is still impossible. But our 3RV20 is not only a combination motor controller, it is also a manual motor controller. It is also tested as a manual motor controller. And now I can tell you what is new, because you see here in the text, it's original text of the new standard, that a manual motor controller, if it's marked suitable for tap contactor protection, and these are in all our 3RV20 are suitable for tap contactor protection, then we can use them as supplementary overprotection. Then, if the power is picked up from the load side of a motor branch circuit protection. Yes, you see here in the drawing, I made this drawing to make it simple. Yes, you see here the red line, we're picking up not anymore from the feeder circuit, we are picking up on the load side from the branch circuit protective device. And then we can use a manual motor controller with tap contactor protection as a supplementary plan. It's not 100% protection, yes, but we can use it also right now. What is now the improvement? If you look in our certification of compliance, there you see that our 3RV20s tested as manual motor controller. You see here this. They are tested as manual motor controller. They have this tap contactor protection and they are suitable for overcurrent protection for a control transformer. And everything is okay. And you can use them also for power supplies, of course. There's another application concerning this protection. For example, in America, a lot of people love these group installation. If you have a group installation, then you have a branch circuit protection device here. Here the circuit breaker is a group protection device for our group installation. Then we have in the group installation, we need these motor loads. And if you have a motor load, of course you have a motor branch circuit protection device. And if you have this, you can pick up the power now, yes, on the load side of the motor branch circuit protection device, which is the group installation, yes, protection device. You pick up, and then it's only needed to use the 3RV20 as a manual motor controller as supplementary protection device. The next topic, enclosure types. You know, enclosure type, very important, of course. And you know, this is also now written in the table 19.2. And in former times also they have another table, it is 19.3. But the new is now, they don't need anymore the 19.3 table, because they make a renew of the table 19.2. And what is the background behind this? For example, if you have a tested empty cabinet for industrial control plant, you buy it, it is tested, everything is okay. For example, you take this and you will find in the on the door or on the back side, inside, you find a label. And in the label you see here on the right side, it is tested by UL and CSA. And if it's tested by these North American testing labs, then you see here the result is we have an enclosure type number 1, number 3, 12, 4, and 3R. These are special enclosure types, yes, which are tested for this example of our cabinet. But this enclosure type is tested, everything is okay. But what do you think if you're drilling holes into it? For displays, for push buttons, for handle, you need openings to insert components inside. Yes, to have access from outside to the industrial control panel. Then of course you have to think about, yes, after mounting in all these handles, push buttons, display, what is now the combination of all the enclosure type? is better or less or what else, what's happening. And then we have to look now about the individual enclosure type rating of these components which are built in. These have a directly impact on the overall enclosure type of both, of the cabinet and the components. And this is what I call the individual, the components enclosure type rating. And now we create the new table 19.2. To have an understanding how to use this table, first of all, you have to see that on the left side, on the left column, these are the enclosure types ratings of the empty tested cabinet, the enclosure itself. And on the first line, you see here in green the component ratings. This is the headline of this line of all the components. And to match everything together creates a combination enclosure types. So let's make an example. You see here the component ratings from the left side to the right. It started with number 1 and ended with 3S. This is not all of them. If you want to know what are the rest of the enclosure types, please scroll down. There you see it's going further from 3SX to 30. So don't be patient, scroll down, then you find all the other enclosure types of the components. So the idea is now, what we do now, let's talk only about this second table from 3SX to 30. These are the most interesting enclosure types, I think, yes. So for example, let's start with an example. We have an enclosure type of the empty enclosure, which is 1, 3, 12, 4, and 3R. And on the other side, we have here the handle, which is made from plastic. And the biggest enclosure type of that handle is 12. Now we match both together, and then we can see that the combination of all these enclosure types of the handle, including the tested cabinet, is now 1 and 12, not more. So if you build in this plastic handle, you reduce the enclosure type of the cabinet to 1 and 12. That's all. Okay? So if your client says, yes, enough, okay, I like this, it's enough for my application, then you are happy, then you can build in this plastic handle into the cabinet and everything is okay. But maybe your client said, no, 12 not enough. We need a 4, we need a 30, we need anything else. Then you cannot build in this plastic handle. Then we have the next example. You have to remove this plastic handle and replace it with a metal handle. The metal handle you see here got an enclosure type of 1, 2, 3, 4, 4x, 12, and 30. There's much, much more. So now let's have a look what's happening now. If you put in this metal handle, then you see we have a number 4, enclosure number 4, and that creates all these enclosure types. So we have now 1, 3R, 3, 4, and 5. But this is not enough. We have also 4x. You see the 4x here. But the 4x don't bring other results. They are really the same. And we have 12 and 30 created by this metal handle. And then we gain 12 again. So we have not only 1, 3R, 3, 4, and 5. We have also number 12. And maybe this is a good thing. And a lot of clients are very happy about these things. And now you can have all the push buttons displays. You have to look what are the component enclosure type. And with this table here, this is really new, is now okay. And there's also a new, I forgot to tell you, this is here, comes also new, a 4x only for indoor use. Yes, so not only for outdoor, 4x specially, they make another one, an additional one. This is 4x only used for indoor. The next topic. What's about tonight? It's a topic of enclosure access. Enclosure access, it is written in the UL508A in the chapter 66.1.2. And yes, it is made by 6.1, and there was a nice harmonization of the NFPA 79. It's very important. I like it very much, believe me, because it match both standards together. Yes. And what they do, they took the chapter 6.2.3.1, it's enclosure access, from the NFPA 79. I mentioned this in the beginning. And they copy it 1-to-1, 100% directly in the chapter 66.1.2. And this is not enough. They also make another one, the chapter 6.2.3.2 from the NFPA 79, and they copied it directly in the 66.1.3. It is very great. There's no mismatch anymore. I like it, I love it, it's perfect. One thing is now, because a lot of people always ask me in my training, why we need this enclosure access? Which people are involved about this? And there I can show you an article in the NFPA 79. This is the Annex A 6.2.3.1. And this is not written in the UL508A, but this makes everything clear for me. Yes? Because why? The use of Kira tool or enclosure interlocking is intended to restrict access only to qualified persons. We need this Kira tool, enclosure access or enclosure interlocking, that only qualified person got access to the inside of the control panel. And who is a qualified person? Are you a qualified person, Robert? Or I? No, not really. Because why? You see here, the qualified person is the responsibility of the employer. Because the employer is responsible for the safety work in the things. So now, let's start very fast now. We have now 3 options because of the alignment of the harmonization between NFPA and UL508A. We have now 3 options to make the enclosure access, to make this inside. You see this here. If you have hazardous voltages, one of the following conditions should be made to create this enclosure access. The first one is number A. You can use a key or a tool to open the door. Then you are ready. For example, you have an industrial control panel and a sub panel. The sub panel is supplied from the industrial control panel, and you need only to put a door lock into it, and then only a qualified person with a key or a tool is able to open the door, and then the access, and this enclosure access is okay. But there's something I also want to mention. We need, if you want to do this enclosure access, we need a caution marking. By UL, this is the right one. This caution marking tells the qualified person, be careful, disconnect the power only before open the enclosure and close the enclosure doors before restoring the power. This is only a reminder which is necessary for the thing. But there's a little mismatch to the NFPA 79. The NFPA 79 wants to have this warning right now. And I don't like this warning because this warning is more for accepted circuit and not directly with enclosure access. But to make everybody happy, I recommend to put both of the warnings on each of the door outside, and then nobody can discuss and everything is okay. Yes, and you fulfill all these standards. Now let's come to the next enclosure access. Maybe you don't like to use a key or a tool, or your customer don't like this. Then you have the option to use an interlocking system for the door. That means that the main disconnect here interlocks all the doors in a way that none of the doors shall be open unless the power is disconnected. So the doors are locked as long as the main disconnect is closed and you have power inside, nobody can open the door. Yes? And, of course, for troubleshooting, for example, it is necessary that the qualified person is able to open the doors under power. And this is called a defeat procedure. And you see here, this is also new. The interlock shall be permitted to defeat. And if you look in the NEC, the wording shall be permitted means not mandatory. It is allowed, it's okay, you can have this defeat if you are able and you want to have disqualified persons and so on. Yes, and this is also new. In the past, it was mandatory. If you make a door locking system, it is mandatory to have a defeat procedure. It's now not anymore mandatory, it is on your free will. And if you do this defeat procedure, then you have to see that the disconnect means is able to be opened by open doors. So for example, you make a defeat, you open the door under voltage, and then you feel, oh, we have a problem. You have to switch off the power. It shall be done inside of the cabinet. It must be possible to open the disconnect by open doors. And the other thing is, if you are closing the main disconnect by open doors under deliberate action. So the doors are open, the power is off, and then you have to close the main disconnect to bring on the power, but this has to be done by deliberate action. This is what is still remaining in the new UL508A. What is new concerning the door locking system? It's concerning the documentation. So if you make the defeat, it's not mandatory anymore, but if you do this, then all relevant information how to make the defeat procedure shall be written in your documentation. For our solution, we have electrical solution. For PLC, I have a nice program. If you want to have this documentation, which is necessary, then we have here an internet link. You can click on it and you can download all the documentation you have. It's very easy to use this. Okay, the third one is not so important. I never heard about it if people want to do this, but maybe you want to have an industry control panel and everybody, also non-qualified person, shall open it and make resettings and switching on what else. Yes. Then you come to the alternative number C. You can open the door without a key or tool or without the interlocking and disconnection of live parts if you are using a so-called dead front cover. This covers everything. Only the handle of the circuit breakers can be resetted and everything is fine. You find there's a lot of solution by panel boards in your house maybe. You have a house maybe and the light goes off. Then a kit can go down, yes, and switch on because it's pretty safe also for unqualified person. These panel boards has nothing to do with industrial control panels. They have their own product standard, safety standard UL608A. If you're interested in what are the detailed differences between industry control panels and distribution boards, I made a tutorial here on the homepage. You can link directly on it. Yes, it's very easy. It's www.siemens.com/control panel. There you find here, if you click on market access, very easy. You find my tutorial. And then you have a detailed information what are the differences between all the distribution panels and industry control panels. But don't forget, we need also the same warning we talked about the alternative number A, yes, because of the NFPA 79. What is the next point, which is really new, is this is for receptacles. Receptacles I don't like in industry control panel, yes, yeah, very much. But nowadays, UL and NFPA say us, if you want to have a receptacle inside or outside of the panel, inside of the industry machinery, and they can be used with power tools, please don't forget installing GFCI, ground fault circuit interrupter, and this must be tested by UL943, and then everything is okay. A lot of people ask me, hey Max, I have no ideas how to bring a receptacle into my panel. And this is now I create the slides here, because here in Germany especially, they want to have a receptacle with 240 voltages. And this is definitely impossible. This is not anymore possible. If you go to America, we need 120 voltage. You see this here in the text. So please use these type of receptacles. And this special type is also able to put on the DIN rail. So you have a very nice option to bring this in the panel on the DIN rail. So this is perfect. the maximum current is rated current is 15 amps. It fits all to the American wire gauge of 14. It's perfectly here, and this is the only thing I can recommend. How to bring this now to the power lines of 480 voltage? You know this. We need now a single transformer to get the voltage down from 480 voltage to 120 voltage. And this we need a single phase power transformer. And the casing of the power transformer shall be grounded, of course. Yes. And then we can create from the secondary side directly from the terminal to the hotline. The other terminal should also be grounded, like the casing. And then we have the grounded wire on the other side. Yes. What is missing now? We need the protection wire, of course, the so-called system grounding conductor for the receptacle. Now we have 3 wires supplied by one single phase transformer. I think it's very important to use the secondary overcurrent protection device. Please use always a circuit breaker or a fuse. Here we got the 15 amps for our solution. Fits perfectly to the receptacle of 15 amps. Everything is fine. And now don't forget, of course, our GFCI. Okay, and this is proper, this is easy, but this is you have to do with the new UL508A, which is now also the same written in the NFPA 79. Now we come to the last topic, I think, yes, because I like this very much, because it makes the understanding of the UL508A very clear. It's also in alignment with NEC and NFPA because all the American standards make a difference between 2 currents. One is a so-called full load current, abbreviation is FLC, and we have full load amps, the abbreviation is FLA. And in the past, the last 20 years of the UL508A, they are mixing it up. There's no clear definition of this. And now you see all the blue chapters here, and now they create the big differences between FLC and FLA. And I like this very much. And also the wording current rating belongs to the FLC and ampere rating is the FLA. Let's start to explain what is the FLC. The FLC is not written on the motor, it's written in the standard. Yes? And this is also called sometimes standard current because you find it in the standard, yes, in the NEC. And where you find this? You find this in the UL508A in table 50.1 and 50.2. I made a little example. Here you see 50.1 on the left side, left column, we got the horsepower of the motor. This is what you should have. UL tested motor is always with horsepower, so you go into the left column. On the first line, you see the voltage and the number of phases of the motor. Yes. So, for example, 480 voltage is a normal 3-phase motor. This is what I'm working with normally. Yes. And the rest, if you put this table in a dimension, you find in the orange colored values, you find the FLCs. So, on the other side, we have FLMs, and this is also called nameplate current because you find it on the nameplate. You have standard current, which you find in standard, and you have the nameplate current you find directly on the nameplate of the motor. Okay? And this is what now UL is calling it FLA, full load amps or ampere rating. And this makes it very clear. So for the result now, we have on the one side, we have the FLC, the full load current, the current rating, on the left side versus the nameplate current, which is full load amps, FLA, and ampere rating. Now everybody knows now which current shall be used for which application. And now I will show you something. Yes, our nice control panel design, our configuration tool, which makes all the configuration and the design and the engineering of an industrial control panel very, very easy. You can download it for free. You don't need any money, you don't need any registration. You can click here on our homepage, download for free, and then you got this. Yes, you find this here on top of the slide, www.siemens.com/control panel/CPD. And then you have this. You need only some minutes for download, and then everything is fine. If you downloaded it, then you find this icon, tier selection tool, after installation. And then you click on it, and then you find here a nice mask. This is a welcome mask because we welcome you to this nice software tool. Yes. To give you an advice to get a very fast and easy step into this configuration tool, please scroll down from the welcome to the project view. You see this down under. If you click on project view, then the project navigation opens. It's a window. Yes, it will open, and then you click directly on main circuit. Here. If you click on main circuit, then and you can choose between the good and nice American world. I like that, Robert, this is my Stars and Stripes I got in my heart. I love America, so I'm choosing always and ever the news US infeed. I see it's not so my world. I like the US world. Okay, so I take this to make the configuration in the US standards. And here, for example, as soon as you click on it, it has an infeed which is made in standard. It is 90% of all my clients. So if you like it, you take it. You don't need to change it. And then you see here, he's waiting for the electrical load data because the configuration needs electrical load data. And you see here motor load. Let's make it a little bit bigger here. And you click, the only thing you have to click on the electrical load. Then we come to the next window, the configuration of the electrical load. And there you see here right now, at this moment, because the mechanical horsepower of the shaft of the motor in horsepower, US horsepower, yes, it is still waiting for a value. And that is the reason that it's the standard current, the FLC, yes, is 0, because there's no power there. So they start with 0. And also the FLA is 0. And you see this here on the right side, a little drawing, that the power is 0, the FLC is 0, and the FLA is also 0. You see this here on this little drawing here. Okay? So, but now as an example, I'm choosing now 20 horsepower as an example. And as soon as I do this, then the CPT goes in the standard and find this concerning the voltage and the power. We have 27 amps as standard current. Yes? And on the other side, he looks in the Siemens motor catalogs of all the UL motors, tested motors. Then we see that the FLA is 22.5. Is your or the customized motor is not 22.5, then we can correct this here. And then the CPD is able to use these values to comply to the UL508A 100%. And that makes it very good. I like this very much. And so I come now to my end of my things, and I want to tell you the recommendation, if you are now interested in this very nice CPD, in this control panel design, please, here in our US symposium, there's a friend of mine is making also some events to show you what is new of the American side of the control panel design. Please watch here what I show you here in this little sign. Yes, then you can visit the events of control panel design training here in our symposium. Yes.
Max, very, excuse me, detailed information, but I have to say it's also very complex, but which is required in this area. Everyone, if you do require further information, then just contact John Burns. You see his contact data here in the screen, and I'm quite sure he will be more than willing to assist you. Max, once again, great presentation, very detailed, and I'm quite sure you're also willing to answer questions if people have any directed towards you.
Maybe I move over to US and then I 100% for you.
Well, we don't know about that. We don't want to let your expertise go from here in Germany.
Okay.
So thank you very much, Max. Thanks to everyone for joining us. Be on the lookout for further upcoming talks as such. If you like this, just send us a comment, or if anything that we can do different or anything that we can do better, please let us know. From all of us here, we say thank you once more. Have a great day. Bye-bye. Until next time. Take care, everyone.
Goodbye. Thank you. And one word to John Burns. He's a very kind guy. He's very happy and very kindful and very intelligent guy. I like him very much. And please contact him if you have still questions, or if you only want to say hello to him. Yes.
Okay. There you have it, everyone. Take care. Bye-bye.
Bye-bye.